All right, so here to wrap up this section, we're going to be taking a look at deductions. All right, so here, so deductions. So deductions form of a valid argument, right? So for example, let's start off with the statement, if it snows today, then we will go skiing. All right, and breaking it down into a couple of atomic statements, right? That P be the statement, it snows today. And then Q be the statement, we go skiing. All right. So here we're going to introduce something called a deduction here. P implies Q, P, therefore Q. Right? So this is our deduction rule, right? Where we have a couple of statements here where the first two here are called premises, right? And again, we're not bounded by two. So all of them, except the last one, are the premises, and the last one is conclusion. Okay? Now here, this is a very famous type of argument that P implies Q, P therefore Q, sometimes refers to as modus ponens. Right? Now, right, what's going to make this valid, right, is going to be related to our truth table, right? So this is a deduction rule, right? We have a set of premises, and then at the end, these three dots signifying therefore Q, right, the conclusion, right? So what is going to make this a valid argument or a valid rule is that conclusion is true. Conclusion is true given premises are true. Right, so again, the premises true, 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 right? If those are true, our conclusion must also be true, right? In order for this to be a valid argument, right? And we can go through the truth table to see why this is in fact valid. So PQ, P implies Q. All right, so here P, true, 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 false, all the possibilities, false, true, false, false, right? And we saw here that this is true in every case except the true, false, right? When the promise is not kept. Okay, so again, the way you read this is we look at, all right, when is the premise, when are the premises true? P and Q, so P and Q, P implies Q is true here. But then the other one we're given, all right, well, when is P true as well? All right, so then that means that here, all right, we're actually in that first row. All right, so now in this case, right, for this particular one, right, P implies Q is true, therefore, then P, therefore Q, right, and we see that in that row, Q is true. So hence we have a valid argument. All right. Okay. All right, let's go over another example here. So here, so let's say not Q, P implies Q, therefore not P. All right. This one also a famous argument. This one has the name modus tollens. All right, and again, we don't need to worry about memorizing these names. Just if you read other material, sometimes they'll refer to modus ponens, modus ponens, and modus tollens. This is just this particular type of argument, right? So our premises are not Q, and then P implies Q, and our conclusion is not P, right? So again, here, let's look at every possible statement here and their truth table. So let's also include columns for not P, not Q, and P implies Q. Okay, so here for P, true, 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 false, false, true, false, false. All right, and not P is just the opposite of P, so false, false, true, true. Not Q is false, true, false, true. All right, and then our implication, P implies Q, true, false, true, true. Okay, so now let's look at our premises here. So not Q, so that means not Q happens in this row and in this row. Okay. And then, so in either one of those, but then the next premise, P implies Q, well, that only happens here in this bottom row here. Okay, so that is where the two premises are true. So not Q, P implies Q. And now let's look at not P. That is also true, right? So here we have true premises, and we can lead to a true conclusion. So this is a valid argument. All right. Now this would work for quantifiers as well. We can make the statement for all x, p of x, therefore there exists an x, p of x, right? Where if for all x in the domain, p of x is true, and our conclusion is, well, then there exists one, right? If it works for all of them, then one of them for sure is going to be true. All right, now here, keep in mind here, the order of quantifiers is going to matter, right? In general, it matters. You can't just switch them around. You do change the statement, okay? All right, so those are deductions.